Alright, a massless string is attached to a mass m1, which is slung over a massless frictionless pulley connected to mass 2. Mass 1 has a mass of 2 kilograms, and mass 2 has a mass of 5 kilograms. Let's think about what type of problem this is. So, in this problem, they introduce a force of 60 newtons, so there's not conservation of energy, so it's not going to be one of those. And it could be kinematics, but we're talking about force, so let's go with this being a force problem. So the equation for force problems, that is the root of everything, is sum of forces is equal to mass times acceleration. And then, so let's write one of these force equations for both of these masses attached to this pulley. If just in the system, just related to the system, we're not going to look at the whole system being moved up by 60 newtons yet. Let's just focus on in the system. The sum of forces for mass 1 is, let's write free body diagrams and our axes. Pushing down on every object is the force of gravity, so mass 1 times gravity. And then it's connected to a string, so in the upward direction, straight up, there is tension. So the net sum of forces is positive T going up minus the force of gravity. And this is equal to mass 1 times acceleration. Now let's do the same thing for mass 2. Again, there's tension going straight up in the y direction, and there's its mass times its gravity pushing down. So the sum of forces for mass 2 is tension up minus the force of gravity down. And this is equal to mass 2 times acceleration. But we're not done with these equations yet, because we have to think about this in a theoretical way. Let's think about which one of these masses would be accelerating up and which one would be accelerating down. So we know the more massive object is going to have a higher force, a higher downward force from gravity. So 5 and 2. This is the more massive object. It's going to experience more force downward, and this is going to experience a little force downward. And they're connected by a pulley. So the force, if one side of this system experiences a higher force than the other, this side of the system is gonna be pushed up because the weight is unbalanced, and this side of the system is going to be pushed down by gravity. So this less massive object is being pushed up by gravity because it's connected to a pulley and connected to a more massive object on the other side. So we know mass 2 is more massive, so mass 2 is gonna have a negative acceleration since it is going in our negative y direction because it is more massive. Yeah. So we have these two equations, right? This has a negative. We have two unknowns, which are the acceleration and the tension, and we have two equations. So what we can do is we can subtract one equation from the other to eliminate one of these unknowns, which is tension. So let's try that. The tensions cancel out. We can immediately do that. Negative m2g is going to be positive m2g. And then we keep this, mass 1g equals, we keep this again, mass 1 times a, and we subtract another negative, so it's going to be plus mass 2 times a. So this is our equation right now. And what we can do is there's a g in both of these terms, so we can actually factor out g, mass 2 minus mass 1, and we can factor out an a out of both of these terms, mass 1 plus mass 2. And now let's solve for unknown acceleration. So we divide both sides by mass 1 plus mass 2. And these two cancel out, and we get this equation for our acceleration. We know gravity is 9.81, and mass 2 is 5, and mass 1 is 2. So we can plug all these values into our calculator, and we can find the acceleration inside of related to the system, not related to the ground. So 9.81, 5 minus 2 is 3, and divided by 5 plus 2. We get, for our acceleration, 4.2 meters per second squared. So this whole time we've been doing this related to the system. Now let's think about how the system itself is moving. So let's think about this bubble as the system, and the acceleration right now is just within the system, but it's also, this whole system is being accelerated upwards. And let's write an equation for the whole system for a mass times net force equation for the system. Of course, is still equal to mass times acceleration. And we're given that the force that's being exerted on this system is 60 newtons and is being pulled upwards. So it's positive. It's in a positive direction. Let's write some axes down here. So we know 60 is the force. And the mass of this whole system, we're assuming that the string and the pulley are massless, would just be the sum of the two masses inside of the system. So mass 1 plus mass 2 would be 5 plus 2, and this would be multiplied by acceleration. Let's isolate the acceleration. Also, let's write a of s, and let's write a of m, I don't know, in this to not get these two accelerations confused. Let's divide both sides by 5 plus 2. And we get acceleration of the system is equal to 60 over 7, which can be written as 8.57 meters per second. So now we have the two accelerations in this problem. We have to think about this now related to each mass. So basically what we do is we know how the system is moving. It's moving up by 8.57, and then we know how each individual mass is moving. Mass 1 is moving up by another 4.2 meters per second, and mass 2 is moving downwards by 4.2 meters per second. So we just add these accelerations basically to find the true net force, or the net acceleration on these objects. So yeah, we just do 8.57 plus 4.2 for mass 1, since it is accelerating upwards, and then 8.57 minus 4.2. And these are our final values for the acceleration of the individual masses related to the floor instead of related to the system. So for the mass 1, we'd get 12.77. And for mass 2, we would get 4.37. Now, this is the answer to the first, for part I. Now let's do part or I guess I is 1. Now let's do part 2, where the force, instead of being 60 newtons, is 125 newtons. So this is basically the same problem, right? The acceleration inside of the system is still the same, since it's excuse me. Since the accelerations inside of the system are the same, the masses still weigh the same, but the acceleration of the whole system of the pulley connected to the masses, this net force being exerted on the system is equal to 125 now, and this is equal to mass times acceleration still of the system. So again, the mass is just the sum of both the masses, which is 7. So 125 is equal to 7 AS. We divide both sides by 7. And we get the acceleration of the system is now equal to, wait, let's plug this into our calculators. 125 divided by 7. It's equal to 17.86 meters per second squared. And we think about this problem the same way, this section the same way as last section, where we just add the accelerations of the masses and the system, because the system is moving at a certain point and then the masses are moving inside of that system at a certain rate. So mass 1 is equal to 17.86 plus its original, the one we got in the original problem, 4.2, and mass 2 is equal to 17.86 minus this original value. And we again plug this in, 86 minus, or plus 4.2, and we get 22.06 meters per second squared. Oh, let me write the units for these. And finally, 13.66 meters per second squared for mass 2.